combining branch circuits from different voltage systems, such as a 277/480 volts service and a 120/208 volts service, within the same conduit is generally not permitted by electrical codes like the National Electrical Code, or NEC. This separation is crucial for maintaining electrical safety and preventing potential hazards. Firstly, the primary reason for this separation is to minimize the risk of accidental contact between different voltage levels. If a fault were to occur in one of the circuits, having different voltage systems in the same conduit could lead to a more severe electrical shock hazard. For example, if a 120 volts wire were to come into contact with a 277 volt wire within the conduit, the resulting voltage potential would be significantly higher, posing a greater threat to anyone who might come into contact with the conduit or connected equipment. Secondly, insulation breakdown is another significant concern. Electrical insulation is designed to withstand specific voltage levels. If conductors from different voltage systems are run together, the insulation on the low voltage conductors might not be adequate to withstand the higher voltage present. Over time, this can lead to insulation degradation and eventual failure, creating a short circuit or ground fault. Thirdly, complying with NEC Article 300.3 C1, which addresses the insulation of conductors with different voltage systems. This section typically requires that conductors of different voltage systems be segregated unless specific conditions are met. While the exact wording and requirements can vary depending on the addition of the NEC and local amendments, the general intent is to prevent the mixing of different voltage systems in the same raceway or enclosure. This separation is usually achieved by using separate conduits or by providing a physical barrier within a larger enclosure. Fourthly, potential for induced voltages. While less common in typical branch circuit installations, running different voltage systems in close proximity can result in induced voltages in the lower voltage conductors. This is due to electromagnetic coupling between the conductors. The induced voltage may not be high enough to cause immediate damage, but it can interfere with the operation of sensitive electronic equipment connected to the lower voltage circuit. Fifthly, the risk of misidentification. If conductors from different voltage systems are mixed in the same conduit, there is a greater risk of misidentification during maintenance or troubleshooting. Electricians might inadvertently work on the wrong circuit, leading to dangerous situations or equipment damage. Proper labeling and separation of circuits are essential for ensuring electrical safety. Sixthly, harmonic distortion. In electrical power systems, harmonic distortion is the presence of harmonic frequencies in addition to the fundamental frequency, typically 60 Hz. These harmonics can be generated by nonlinear loads such as electronic devices, variable frequency drives, and saturated magnetic cores. When harmonic currents flow through electrical conductors, they can cause several problems, including increased heating, voltage distortion, and equipment malfunction. The NEC addresses harmonic currents in several articles, including Article 220. Firstly, nonlinear loads generate harmonic currents that distort the sinusoidal waveform of the current. These harmonic currents can flow back into the electrical system, affecting other equipment and components. Secondly, harmonic currents increase the root mean square, or RMS, value of the current flowing through conductors. This increased current can cause conductors to overheat, potentially leading to insulation damage and fire hazards. Thirdly, harmonic currents can cause voltage distortion in the electrical system. Voltage distortion can negatively impact the performance of sensitive electronic equipment and cause malfunctions. Fourthly, transformers are particularly susceptible to the effects of harmonic currents. Harmonic currents can cause increased transformer heating, reduced efficiency, and premature failure. Fifthly, harmonic currents can interfere with the operation of sensitive electronic equipment such as computers, communication systems, and control systems. Harmonic filters can be used to mitigate the effects of harmonic currents by reducing their amplitude and preventing them from propagating through the electrical system. These filters typically consist of inductors and capacitors that are tuned to specific harmonic frequencies. The NEC requires that electrical systems be designed and installed in a manner that minimizes the impact of harmonic currents. This includes using appropriate wiring methods, overcurrent protection devices, and grounding techniques. In some cases, harmonic filters may be required to mitigate the effects of harmonic currents. Seventhly, overcurrent protection is another area of concern. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. However, if conductors from different voltage systems are mixed in the same conduit, it can be difficult to properly coordinate the overcurrent protection devices. For example, a fault on a 277-volt circuit might not trip the overcurrent protection device on a 120-volt circuit, leaving the lower voltage circuit unprotected. Eighthly, ground fault protection is also an important consideration. Ground fault protection devices, such as ground fault circuit interrupters or GFCIs, are designed to protect people from electrical shock by detecting ground faults. However, if conductors from different voltage systems are mixed in the same conduit, it can be difficult to ensure that the GFCIs will function properly. A ground fault on a 277-volt circuit might not be detected by a GFCI on a 120-volt circuit, leaving people at risk of electrical shock. Ninthly, accessibility and maintenance can be compromised. When different voltage systems are combined in the same conduit, it can make it more difficult to access and maintain the electrical system. Electricians might have to shut down both voltage systems to work on a single circuit, increasing downtime and inconvenience. Tenthly, the code requires clear labeling and identification of all electrical circuits. If different voltage systems are mixed in the same conduit, it can be more difficult to properly label and identify the circuits. This can lead to confusion and increase the risk of electrical accidents. 11thly, the NEC provides specific requirements for the separation of different voltage systems in healthcare facilities. These requirements are intended to protect patients and staff from electrical shock hazards. Mixing different voltage systems in the same conduit could violate these requirements and create a dangerous situation. 12thly, industrial settings often have complex electrical systems with multiple voltage levels. The NEC provides specific requirements for the separation of different voltage systems in industrial facilities. Mixing different voltage systems in the same conduit could violate these requirements and create a dangerous situation. 13thly, commercial buildings also have specific electrical needs. The NEC provides specific requirements for the separation of different voltage systems in commercial buildings. Mixing different voltage systems in the same conduit could violate these requirements and create a dangerous situation. 14thly, the increasing use of energy-efficient lighting, such as LED fixtures, can also impact the design and installation of electrical systems. LED fixtures often operate at different voltage levels than traditional incandescent or fluorescent fixtures. Mixing different voltage systems in the same conduit could create compatibility issues and increase the risk of electrical problems. 15thly, renewable energy systems such as solar photovoltaic or PV systems are becoming increasingly common. Solar PV systems often operate at different voltage levels than the building's electrical system. Mixing different voltage systems in the same conduit could create safety hazards and violate NEC requirements. 16thly, surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. SPD are typically installed at the service entrance and at branch panels. If different voltage systems are mixed in the same conduit, it can be difficult to properly coordinate the SPD. A surge on a 277-volt circuit might damage equipment connected to a 120-volt circuit if the SPD are not properly coordinated. 17thly, arc fault circuit interrupters, or SIs, are used to protect against arc faults, which are a common cause of electrical fires. SIs are typically installed on branch circuits that serve bedrooms and other living areas. If different voltage systems are mixed in the same conduit, it can be difficult to ensure that the SIs will function properly. An arc fault on a 277-volt circuit might not be detected by an SI on a 120-volt circuit, leaving people at risk of fire. 18thly, tamper-resistant receptacles are required in many locations to protect children from electrical shock. These receptacles have shutters that prevent foreign objects from being inserted into the slots. If different voltage systems are mixed in the same conduit, it can be difficult to ensure that the tamper-resistant receptacles will function properly. A child might be able to insert a foreign object into a 277 volts receptacle if it is located next to a 120 volts receptacle. 19thly, emergency lighting systems are designed to provide illumination during a power outage. These systems typically operate at different voltage levels than the building's normal lighting system. Mixing different voltage systems in the same conduit could create compatibility issues and increase the risk of electrical problems. 20thly, fire alarm systems are used to detect and alert people to a fire. These systems typically operate at different voltage levels than the building's electrical system. Mixing different voltage systems in the same conduit could create compatibility issues and increase the risk of electrical problems. 21st, communication systems such as telephone and data networks also have specific voltage requirements. Mixing these systems with power circuits in the same conduit can lead to interference and performance issues. The NEC has specific guidelines for separating communication circuits from power circuits to minimize these problems. 22nd, control circuits for machinery and equipment often operate at lower voltages than the power circuits that supply the equipment. Mixing these control circuits with power circuits in the same conduit can create safety hazards and interfere with the operation of the equipment. The NEC requires that control circuits be properly identified and separated from power circuits. 23rd, the use of flexible metal conduit, or FMC, and liquid-tight flexible metal conduit, or LFMC, is common in many electrical installations. However, these types of conduit can have limitations on the types of conductors that can be installed in them. Mixing different voltage systems in FMC or LFMC could violate NEC requirements and create safety hazards. 24th, cable trays are often used to support and route electrical cables in industrial and commercial buildings. The NEC has specific requirements for the separation of different voltage systems in cable trays. Mixing different voltage systems in the same cable tray could violate these requirements and create a dangerous situation. 25th, underground wiring also presents unique challenges. The NEC has specific requirements for the burial depth and separation of underground electrical cables. Mixing different voltage systems in the same trench could violate these requirements and create a dangerous situation. 26. When working on existing electrical systems, it is important to be aware of the potential for hidden hazards. Mixing different voltage systems in the same conduit might not be immediately apparent. Electricians should use caution and follow proper safety procedures when working on any electrical system. 27th, the use of proper grounding techniques is essential for electrical safety. The NEC has specific requirements for grounding electrical systems. Mixing different voltage systems in the same conduits can complicate the grounding process and increase the risk of electrical shock. 28th, electrical inspections are an important part of ensuring electrical safety. Electrical inspectors are trained to identify potential hazards and code violations. Mixing different voltage systems in the same conduit is a common code violation that inspectors will look for. 29th, ongoing maintenance and testing are essential for maintaining electrical safety. Electrical systems should be regularly inspected and tested to identify any potential problems. Mixing different voltage systems in the same conduit can make it more difficult to properly maintain and test the electrical system. 30th, the NEC is constantly being updated to reflect new technologies and safety concerns. Electricians should stay up to date on the latest NEC requirements to ensure that the work is in compliance with the code. Mixing different voltage systems in the same conduit is a topic that is frequently addressed in the NEC. Therefore, in conclusion, combining branch circuits from different voltage systems in the same conduit is generally not permitted due to safety concerns and code restrictions. It is always best to consult with a qualified electrician or electrical engineer to ensure that your electrical system is safe and in compliance with all applicable codes.